Good morning, everyone. Welcome back, and thank you for joining us. We're glad that you're here. I'm Steve,
And I'm Scott.
and together we are Backyard Musings, the Science and Technology channel.
Yeah, and today we're talking about Hawaii and volcanoes. And this is kind of a big deal because Hawaii is like one big volcano, right? Just about. And part of the Pacific, what do they call it? Pacific plate or Pacific rim of volcanoes, which I think also contribute to earthquakes. And I don't know if we're going to get into that, but anyway, just my opinion. So here we go.
Rising mantle temperatures and two heat surges may explain why some Hawaiian volcanoes grew exceptionally large. A 2,200-mile trail of volcanoes records the Pacific Plate's slow passage over the Hawaiian hotspot. Instead of cooling through time, as geologists have generally expected, the mantle plume beneath this chain appears to have warmed by about 480 degrees Fahrenheit during the past 447 million years. Would you like to know more?
The finding, led by earth scientists at the University of Hawaii at Manoa, challenges the long-held view that hotspots begin extremely hot and gradually lose heat. Reported in Earth and Planetary Science Letters and published on June 8th of this year, the research also linked two periods of unusually high plume temperature to the formation of the largest volcanoes in the northwestern and main Hawaiian island chain.
The Hawaiian Ridge contains 65 volcanoes formed as the Pacific Plate moved across a hotspot fed by hot material rising from deep within the earth. So the hotspot is way down below and it stays. And these plates are moving. So you get one, for example, you'd have the volcano on Oahu, which I can't remember, Diamond Head. That formed millions of years ago. And as the plates were pushing, then Haleakala on Maui, that volcano formed, and it kept pushing until it got to the Big Island. The Big Island came over that plume, and now that lava is coming up from that volcano, and it'll just keep moving over the millions of years. Okay. Yet the amount of lava produced along the ridge varies by roughly 100-fold, leaving researchers to determine what caused such dramatic differences in volcano size.
A group led by Michael Garcia, Emeritus Professor of Earth Sciences in the University of Hawaii Manoa School of Ocean and Earth Science and Technology, examined olivine basalts from 16 volcanoes. The researchers tested four possible explanations for the changing lava volume: variations in lithosphere's thickness, differences in the magma source, changes in the speed of Pacific Plate, and shifts in mantle plume temperature.
Yeah, it seems like all four of those would be culprits. Quote, "It was a major surprise to find such a strong direct correlation between mantle temperatures and volcano size," said Garcia. "Other potential explanations simply failed to explain the data. To reconstruct temperatures deep beneath the volcanoes, the researchers developed a new geothermometer that estimates how hot lava was when it originally formed in the mantle. They then compared those temperature estimates with updated measurements of volcano size derived from extensive ocean floor surveys."
Together, the two data sets allowed the researchers to trace how plume temperature and lava production changed across millions of years along the Hawaiian Ridge. The results point to an overall rise in lava temperature interrupted by two major surges of heat. One occurred 14 to 20 million years ago and produced Puahonu, okay, the largest and longest-lived shield volcano formed within the past 60 million years. The second occurred 0 to 6 million years ago and contributed to the formation of the Hawaiian Islands.
So 0 to 6 million, that could be yesterday.
Yeah.
Zero.
Yeah, 0 million years ago.
Okay. Quote, "The development of the new geothermometer allows one to better understand the history of volcanoes and why some are larger than other volcanoes," Garcia added. The researchers suggest that the plume's long-term warming may be connected to the movement of dense, hot material within the lowermost mantle.
And what you said earlier about it could have happened yesterday. I mean, Hawaii their volcanoes are active. Not all of them, but there's a lot of them active, right? I mean, you hear about lava flows. I mean, again, not yesterday, but within the last decade or so, they've had some volcanic activity there. So that's pretty recent.
Within the last 50 years, it's been continuous off and on.
Right.
Look at Tonga. Those volcanoes, the satellite images catches the explosion of those volcanoes. They're so close to the surface.
Yeah. Yeah. And not a whole lot of place to run when that kind of stuff happens, right? I mean, it's not like
if you're out there fishing, all of a sudden, boom.
Yeah. Yeah. Or hiking around one of these volcanoes. I know that's a pretty common recreational activity, right? Hiking or there's that one volcano. You probably know the name of it. You can drive to the top, right? And it snows there. I forget
Mauna Kea.
Okay. So, and that's on what? Is that on the Big Island?
Mauna Loa and Mauna Kea are on the Big Island.
Yeah. So you can be at the beach and then drive a few miles and you're in
snowboarding,
freezing weather. So yeah, pretty crazy.
Yeah.
But anyway.
All right, folks, thanks for joining us. We hope you enjoyed this Earth Sciences segment.
Yep. Take care. We'll see you this afternoon.